Hi guys, my name is Alan Sutherland and I'm here to present to you my slideshow on cross-continent communications, an undersea infrastructure. So let's get right to it. So some questions that one may ask themselves is how does data get to other countries or other parts of the world? Or how does that email I sent to my friends in the UK get across the pond, as they say? Or how did the hackers in China even access companies in the US? I mean, that's pretty amazing how data can traverse all the way across the world in a matter of a blink of an eye. So unbeknownst to many, there are data cables that run across the ocean floor all over the world. And these data cables are laid across and on top of the ocean floor, on the ocean bed. And they're used to carry a very high rate of speed of data, up to 1.2 terabytes of data per second. So imagine having that at home instead of DSL. So what is an ocean-bearing data cable? Well, it's a cable with many protective layers. It's a cable that has a very thin fiber optic cable right in the center core, which carries the data. It can run and span many kilometers. We're talking thousands of kilometers, and it can also be installed at great depths, up to 8 kilometers under sea level. So the picture you see on the left is actually they chopped up one of the pieces of cable and gave you a cross-cut section so you can see how the cable is built. And we'll get into that in the next slide. But on the right is an interesting device. It's called a repeater. And what this does is it takes the optical signal. After every few hundred kilometers, they have to install one of these, because if not, the signal will degrade. So what they'll do is convert the light into electricity, and then amplify it and convert it back to light and send it out the other end. So here's the first couple layers. And if you look, the first layer is polyethylene. The second is just the tape that holds this third layer, actually, which is the metal that gives the cable its strength. The fourth, fifth, and sixth are just to keep water from getting in. And layer 7 is a petroleum jelly that protects the fiber, which is layer 8. So in this picture, you see a cutaway of cable from 1858. Now that cable was an original telegraph cable they used to span the Atlantic Ocean from Europe to the United States. And the cable on the right obviously is a modern day fiber cable. That little white dot in the center is the actual fiber. So how do these cables get there? You know, I asked myself the same question a few years ago, and recently I did some research and this came up. I don't know what, I don't know if it's true. Some say this guy had something to do with it. You can look it up yourself. But all kidding aside, these cables do need special equipment. As you see here in the picture, this is a picture of the same ship, just twice. Has special rollers and special bins inside the ship that hold the cable. You'll see in a video clip soon. Back to the 1858 cable installation, they ran a cable from the United States to the UK to have telegraphic communication. This is a modern day map of the cables that are run across the ocean floor, at least in this section of the world, the Atlantic, Caribbean, Central and South America. Now here's a closer look at the Caribbean area, and you can see the major junction point, which is South Florida. I live in South Florida, and in the next slide I'll actually show you where the junction point is, or one of the major ones. Here you see what's called the NAP of America, is also referred to as Terramark or the Verizon Terramark building. Now NAP stands for Network Access Point. So all the cables that are coming from South America have to juncture here. They have to connect here before they go anywhere else. So this is like the main hub for all South America and the Caribbean. Also, I didn't know this, but the NAP is one of the K-root DNS servers in the world, which there are very few of. If you look closely at the map, you can see where the cables originate in South Florida. Again, if you're familiar with the area, you know what I'm talking about. Now here's a short clip I'll show you
The project required an extensive marine survey of the ocean bed along the entire route to minimize environmental disturbance and avoid possible seismic disruptions. To meet the project demands, the latest fiber optic cable technology has been used, ensuring maximum speed, efficiency and reliability. To begin the 14,000 kilometer subsea route, the cable is loaded directly from the factory onto ships. The cable is stored on gigantic reels in the ship hull and routed to the rear of the ship. The repeaters and splitters necessary for boosting the signal and diverting the cable at the planned landing stations are connected on the ship. A plow is used to bury the cable under the ocean bed. The cable is split and diverted to the landing stations. From the landing stations, backhaul networks carry the signal to the end users.
So once a cable gets to the landing stations, as I refer to it, gets to shore or the hookups, they begin to test the signal, and then once that passes, the customer or the country has a solid connection to the rest of the world and also the NSA, mind you. So please feel free to ask any questions and comment on the video, and I left some good sources there. Thank you for watching my presentation. Have a great day.